For the last tutorial this week, let's look at shot type classification. So we're going to open up this notebook. This is the first notebook where we actually need to use a GPU. So let's go through the steps again on how to set that. For this notebook, you can kind of run any of the GPUs. What I would say is it kind of matters, like how long do you want this process to take, how many files do you have, clips to render, that sort of thing. Anyway, the way to change this is to go to runtime, change runtime type. Let's try that again. And then you're going to select one of these GPUs. For most of you, a T4 is probably fine. I'm going to select a V100 just to speed up our tutorial a little bit. The other thing I recommend is make sure you turn on high RAM. I've noticed that with some of this, if you use the basic RAM setting, it will crash eventually. I've sort of built up the notebook to sort of work around that in that case, but just to be safe, set it to be high RAM. And now we want to check to make sure we're actually getting the right GPU here, so let's go ahead and run this first cell. And it's going to initialize, and it's going to tell us, in my case, I am using a V100. Next, we want to connect the drive, as always. And then we're going to need to install some code here. So we're going to run this just to install everything. And while we do that, let's go ahead and set up our folders here. So we'll go into Drive, My Drive, Algo Film. And then what I recommend we do is inside this Algo Film folder, let's go ahead and make another new folder, and we'll call it Models. So for machine learning, since this is the first sort of deep learning process we're going to use for this class, we always need a model, and this model has been previously trained on data. So in this case, this is a custom trained model that I trained just for this class, and it was trained on a data set that was pre-labeled. So basically it was a bunch of video clips, and they were labeled with the 5 shot types. So I went ahead and trained it, and now we have a model file. Now you're going to need to download that model file. And the way to get that is using this line here. So what this is going to do is it's going to download a file from my Google Drive, and it's going to save it into your Google Drive. And let's just make sure we have the folder structure here right. So let's go ahead, and it looks like inside of models we want to make another folder. Let's make a new folder in here, and let's just call it, shot type. That way we have exactly what we know, because we're probably going to have a couple additional models throughout class. So for now, let's save this here. So what I want to do is I want to save this path. So I'm going to copy this path, just right click and hit copy path. And I want to paste this in for the -o part. So basically this is saying is download this file from my drive into your drive and put it in this location. So we're going to go ahead and run this. And these models are, it looks like this one's about 700 megabytes. I think there's a couple others as well. So again, you're going to need maybe a gigabyte of space for these files. So just be aware of that. And they should download pretty quickly because we're going from crazy Google server to crazy Google server, which is pretty fast. All right, and at that point we're done. And if I open up this folder, I should see a bunch of files in here. So that's all we need there. Let's go ahead and close this out. Now we're going to do what's called inference. And inference is, say, like, you've got training and inference. So training is we train this model. It took me a couple days to train the model. I will probably go through a process like this later in class for people that are interested in training their own models. But for this one, let's just use the model that I trained, in part because it's already trained on a general data set, so it's going to work for everybody. Inference is actually when you use that model to test out your own data. So what we're going to do is we're going to feed this model a bunch of video clips that we have, and it's going to then return like what it thinks the shot type process is. So for that, we're going to need to actually load in our model here. So what I recommend we do is let's just copy this path here and replace this here. And what this is going to do is it's going to load in the model files. So we'll go ahead and run this. And this again takes a couple seconds because these are pretty big files. All right, that's done. And now we can run this cell. This cell is just a bunch of functions that we're going to use later. So go ahead and run that. Okay, so now we want to do, I need to add some text here. Let's do test on a single file. So what we want to do is we want to take a single clip here and just see what the model decides the answer should be, or what the shot type is. So I'm just going to go into my clips folder, and I'm going to grab a random clip here. Let's say, I don't know, let's grab from this here. Let's grab from Punch Drunk Love, and we'll just grab a random one. And I'm just literally going to go in and grab a random one. And what we're going to do is here we'll paste in the path. Actually, let me do one thing real quick. Let me turn this into a file for us. So give me 2 seconds to do that. Okay, so I just added a little bit here to make this a little bit easier for us to work with. So now we have the video path over here as a string. So you can just copy any of these paths here and paste it in. And this is our path now to the video file, and we can go ahead and run the cell. And what it's going to do is actually just going to convert this into a little GIF so we know what the video looks like. And then we'll be able to sort of guess from there what we think the label should be, and then we'll run it and see if we actually get the right answer. Okay, so here is my clip. This is going to be funny because I bet we're going to get the wrong answer here, or I bet we're going to get something like the wrong answer. So if I look at this, technically behind this image is probably his waist. So this should probably be a medium shot. But if I had to guess, I'm going to guess it's going to say a close shot because it only sees the face here. Let's run it and see what happens. But that's kind of my guess, is that we might get the wrong answer. And this is a great example of, you know, you think in an ideal world, like you as a human know what these shots are, and therefore the model should be able to match up to it, right? You don't always get that answer. So let's run this and see what we get. This next cell will actually run the classification, and it will spit out what we think the answer is. All right, and it spit out, what is the answer? It spit out long shot, which is interesting. I can kind of see why it might think this is a long shot. It is kind of like expansive in the background. So this one, it got wrong. Now, if you look at this line here, you'll see that these are actually confidence scores. So again, remember that a machine learning model is not giving you what it knows to be the answer. It's going to give you actually a set of probabilities, or what it thinks are the probabilities for these images to be scored in a certain way. And if you look at this, it says that this index had the highest confidence after this one, this, and then it sort of is, these are all negative. So it's whatever is the highest positive score. And you'll see that it gives us then that index, which is 0, 1, 2, 3, 4. And it has decided that that means that it is matching up to the index of long shot. Now, this is kind of the problem with these tools. This is not entirely accurate. In testing this model or training this model, I found that it had about 80 to 85% accuracy. And this is a great example of where it isn't really accurate because there's probably no data in the model where someone's whole body is actually blocked, and therefore it's not labeled correctly. So there's interesting things that happen with these models. So again, this will not be perfect, but it will give us some general idea. Let's grab a different cell or a different copy, or copy a different video file, and let's paste this one in. Let's run this. All right, and here is the file. And if I had to say, I would think this is going to be a close-up. You might want to call this a medium shot, but the problem here is, and this is where it gets somewhat more, arbitrary rather than like a pure science, is medium shot is technically waist up. And we don't, this is like halfway through his body. So is this a medium shot? Is it a close shot? Some people even call this a medium close shot, which is, again, these things get to gradients. But let's see what the model thinks this is. And it gives us close shot. So in this case, this one's correct. And this is honestly what I found, is that in a lot of cases, it gives fairly accurate results, 80%, 85%, but it will not be perfect. And we'll have to deal with that later, and we'll talk about some of the strategies to deal with that as we get further along in the class. So now we have sort of a single file here that has been processed. But obviously, we want to now process that, save it to our JSON, and we actually want to run it on every clip within our model. So let's take a look at how to do that in the next cell here. So now what we want to do is we actually want to process all of our JSON data. And what this is going to do is now it's going to run through every video clip in a folder, and then it's going to copy that to the JSON path and then save it out. So the first thing we need to do here is actually set our JSON file. So remember that for most of us, it should be in the root folder of algo film. So we'll copy this here and we'll paste this in. Now the reason we want to actually work off of this file is that one, we've saved a bunch of other data previously, right? So we've saved out duration, dimensions, video path, etc., etc. So we want to make sure we're pulling from this. The other thing is, because this is a fairly slow process and because sometimes things can break, I've set it up to save back to the JSON file intermittently as it runs through this process. This process does take a couple seconds per video, so therefore we don't want to redo that process over and over again. It's going to be a waste of our time. So there's a bunch of stuff, a bunch of code in this cell here that actually checks to make sure the answer hasn't already been, or the probability, the shot type classification hasn't already been saved to that path. And if it has, it's just going to skip it and go on to the next video, and that'll make this process a little bit faster each time. The other thing that's here is, let's say you've already run this on a bunch of videos and you just added a new video type, or sorry, a new film to your video data set. This filter will allow you to sort of like exclude other videos from your video and only process those. So let's say when I go to clips and I go to Punch Drunk Love, you'll see that all of these files begin with Punch Drunk in this case. So let me just copy this and let's just paste this in. And what this is going to do is it's only going to look at files in this Punch Drunk Love folder. It's going to look for matches here. And it'll skip these other files. And that again is like, we don't want it running over everything in case you're like on a timeline or in case you just want to look at a particular piece of film. So let's go ahead and run this now, and we should see, as it begins to run, is we will see that it is saying some things have already been classified. And it's skipping those classifications. And now at the bottom here, it is actually telling us I am processing these files and is spitting out a classification per video, right? So we're seeing, the first clip was extreme close-up. The second clip was a long shot. Third clip was a long shot. Fourth clip was a medium shot, and on and on and on. Now you'll see this is not the fastest thing, right? It is taking, 1, 2, 3, like 6 frames in, or 6 clips in, and it took about 30 seconds. So it looks to be taking about 5 seconds per clip. Now, if I have 2,000 clips times 5, that's going to be 10,000 seconds. What does that convert to in minutes? So that is 166 minutes. So that is 2.5 hours. So this is not a fast process. If you want to shorten the speed, you can use an A100, which is the faster GPUs. Problem then is that you're going to burn through a lot more credits doing that. And I'm not sure it's actually worth, it doesn't scale the way you might think it does. It's not like it's going to be twice as fast and you're going to only burn through twice as many credits. It actually is a little more credits because it's a newest GPU. So in this case, we do have to be kind of just patient. Again, this is also why we're saving to the JSON file, so we never have to do this again for these video clips. Once this is saved, we'll just keep that forever, and we'll never have to worry about having that data again. So what I'm going to do is I'm going to let this run until it finishes. I'll stop the recording and then we'll come back when it finishes. It may actually be an hour or two. I don't know. We'll sort of see how long it takes. And I'll be back when that's done. Okay, and we're back. This finished processing. I wasn't paying attention to how long it took, and then I ran another cell just to double check something. So I lost track of how long that took, but I want to say it was about 15 minutes for about 280 280 clips. So, not the fastest thing in the world, but also not the slowest. And the good news is that all that data is now saved. So the key to remember here is, only want to run this once per file, because doing that multiple times is kind of a waste of computation power. One thing I will mention is at the end of this cell, after you've run everything here, if you do get an error message, which might happen, drop what the error message was in Slack, and I can try and make sure I fix it. There's a couple different things that could happen here. One is that if your clips are too short, it will skip over really short clips. This model requires at least 16 frames of content in order to do the classification. In those cases, it will skip over anything that's shorter than that. There are other issues, like I know there were some glitchy things with PyScene detect for some folks that in those cases we are skipping over those files. I would probably always recommend that at the very end you run this cell just to be safe. That's this cell that makes sure we save all that content back to our file. So let's just run this to be safe. If you do get an error message and this stops, make sure you run this as well. That way you'll make sure you save any of your work. Okay, at this point, we are actually done with the classification that requires a GPU. So what I recommend we do is we actually restart the notebook back in CPU mode just to do the sort of assortment and that sort of thing. So let's go ahead and go back to this. We'll go to runtime. We'll go to change runtime type, and we'll go to CPU. And we'll say yes, okay, and we'll hit save. So the notebook is going to restart then. And we're going to have to go back to the top of our files here to rerun things. So again, this time we should see an error message. There it is, command not found. We'll connect the drive again. And I recognize this adds a little bit of time, but this is actually going to save us some credits in our collab, especially because depending on what you're doing with this, the rest of this notebook, it can take a while to do this stuff. Okay, looks like that's finished. And now we can skip over some of this stuff. I think we can actually skip over all of this and go down to where it says save to JSON file. Nope, we're skipping past that one. Sort by shot type. So this time we're going to do some sorting. So just like we did previously, let's try and actually take a look at some of our work. And this will also be a good way to test to see if the classification worked fairly well. Again, it's not always super accurate, but it'll give us a sense of how well it worked when we look at this. So let's go ahead and run this first cell. This just sets up, again, another function for us. And then we've got here, we've got our JSON path. So again, we want to load back in our JSON data. And now what we want to do is let's collect all of the clips of a certain shot type. So let's go ahead and collect everything that is CS. Remember that we saw before that there were some issues within these areas. So we want to sort of think about maybe what we saw was the most inaccurate. Let's try long shot for now. I happen to know that with my data set, there are the least number of clips for a long shot, which means this will process fairly quickly. The other thing we could do here is let's say we only want to look within Punch Drunk Love. If you recall, our file name was, for those was, what was it? It was, not that one. I think it was just cap punch drunk. Was that right? Maybe? No, punch dash drunk. So what this will do is it'll only look for the long shots captured under the Punch Drunk Love. Now, if you delete this, this will give you everything from your data set, which is good. It's helpful to see that. But maybe when you're working on processing an individual film, you just want to double check and make sure that you got the right results there. So let's go ahead and run this. And here are all the file names we got. And we'll see there are 27 total clips for this particular process. And actually, for everyone, I'm going to save us all a little bit of headache and hide this print. So you will not see this print. You will just see at the very end, you will see a number. And it will say, this is how many clips are in this. If I remove this value and run this, you'll see my video data set has 224 long shot clips. That's a lot of clips to process all at once. So let's just look at just the Punch Drunk Love. Okay. Next, we want to combine all these into a single file. And this is just the previous process that we ran for doing the combinations of different dimensions and files. So in this case, what we want to do is we'll set up where we want to save the file. So let's call this Punch Drunk LS. And then let's talk about max height and width. So again, this is going to create that padded option. I find that this is best for shot types just because you don't want to really crop into shot types because the cropping can sometimes lead to inaccuracies or you might look at something and say oh, that should be a close shot, but it's really actually a medium shot because of, I don't know, the cropping left and right. I happen to know that this video is, I believe, 1920 by 800. So I'm just going to leave it at that dimension, and that way we're not doing a lot of padding, we're just cropping in. Or actually, we're not cropping in at all, we're just using whatever is the default dimension in there. At this point, we know what all this code does. It should just generate a padded video file that concatenates all the various clips together. So at this point, we can run this. And as you know, the resolution of files plus the number of files is going to lead. This will probably take about 10 or 15 minutes to produce. Not ideal, but it works. And you'll see here again that it goes through the same process of generating a temporary folder, and it's going to produce a bunch of clips in there, and then it will convert a concatenated file. This will take a while, so I actually don't want to stop and wait. What I'm going to do instead is I'm going to show you what one of these files looks like. So I ran this process previously on all of the clips from my files, and this was on all of the close shots. So here is what this looks like when this finishes running. So you'll see here that there are some images that are padded or letterboxed, and then there are some images, let's see if we can find out where those are, probably toward the end here, yep, that are padded all the way around. So this is taking the natural dimensions. It just sort of gives you a sense of what these shots are. Now already I can tell this is inaccurate in a lot of places, right? This is not a close shot. This is clearly a full shot because you see all of the children and their whole bodies. That's probably a close shot. Some of these are looking okay as close shots. So you can kind of scrub through here and begin to see, like, again, some of these are probably more what we would call like a medium close shot, right? They're like from the chest up rather than the waist up. And this is kind of the challenge with this model, is it's not super accurate because of people are sitting down, or, is this person close shot, but this person is in a full shot, or actually I guess a medium shot. This is kind of the challenge of some of these tools, is that even the language is a little arbitrary, so labeling them can be a little bit arbitrary. But I would say in general, this looks pretty good. Close shot tends to have the widest range, I would say, from my perspective, of like what is a close shot and what isn't. So this will generally contain a good selection of films. Now my guess is the reason some of this isn't looking good is probably because, one, it's black and white, and two, because I don't know how many kids are in full shots in my data set. So this might be a case of where, like, if I really want to make a much more accurate model, I might go in and label some additional data and train the model a little bit longer on that additional data. I think especially people laying down in bed, very hard to classify these particular shots because, it's really about people. Objects are kind of the same way. There's some sense of like what an extreme close-up on an object looks like, but like other things are a little bit harder than that. So in general, not the most accurate language for these tools, but we're trying to do the best we can with what limited data we're given. So this is how you can combine these shots. Now again, you could also go back to our notebook and collect all of the long shots, all the full shots, all the medium shots, all the close shots, and all the extreme close shots. And you could process it per film. You could process it across all of your films. And you can sort of play with this. So this is a good example of just starting to get into using classifiers. One thing I should also note is we've also stored the confidence score. So remember that we were getting confidence scores back from these. So this particular image, this one was a close shot. The highest score was actually, is this one. So it's 9.56. So that's actually a fairly high confidence score. I'm storing the confidence scores in the JSON as well, because what we might actually want to do is just filter by confidence score at some point. Actually, maybe what I'll do is I'll add to this notebook that we filter by confidence score. So I might add a confidence score filter here and just look at very highly confident images, because my guess is that some of the ones that we're sort of like, that's not really accurate, if we look at the confidence scores for those, they're like lower. They're in the 2s versus the 9s. And that means if we filter those out, we're more likely going to get more accurate data. That's kind of one of the nice things about using machine learning models. They do, especially for classifiers, they do give you a score. And you can use that score to say, like, hey, if it's below a certain confidence, like, let's kick it out. And that way we're not worrying about having, like, bad data in there. So I'll actually add that to this notebook. So when you come back to this, you'll see that there. And then we'll filter by that as well. And then we can process that data. So that's it for this week. Next week, we're going to go way, way deep into doing classifiers and actually look at the content inside of our images. So we'll be able to say like, maybe who is this person in this video? Or are there cats in this video? Or are there coffee pots in this video? That sort of thing. So we'll talk way, way more about classifiers and how to train them and how to use them and that sort of thing. But this is a nice intro to that. So look forward to that next week. Again, I really look forward to seeing what people make this week. This week is, again, just getting started, but as we're building up all these tools, we're going to have a really, really powerful tool set by the end of class. So I'm looking forward to that. So I'll see everyone next week. Thanks.